Hello everyone, myself Ravi Gatti, Assistant Professor, Department of Electronics and Communication Engineering, Sri Venkateswara College of Engineering, Bangalore. I am going to handle this course, Information Theory and Coding, and the subject code is 18EC 54. This subject you are going to study it in the 5th semester. Now, let us look into the syllabus. So the entire subject, this Information Theory and Coding, has been divided into 5 modules. In the module 1, we are going to discuss about the overview of information theory and coding. So when we talk about information and theory and coding, it is necessary for us to know what we mean by information. So once we understand the information, the next step is how we are going to calculate or how we are going to measure the amount of information present in the given message. It is necessary for us to know. So we will be using some logarithmic scale values. So with the use of this logarithmic scale values, it is possible for us to know the amount of information conveyed by a source or the amount of information generated by the source we will be getting to know. So this information we are going to learn in the preliminaries of the module number 1. So once we understand how to calculate the amount of information in the given message, the next step is, so what is the amount of information which is being carried out by the source? If it is emitting some finite number of symbols, it is necessary for us to know. So we will be using one of the important terminology called as a entropy. So we will be studying about what we mean by entropy and how we can calculate the entropy. And generally, there are two types of source symbols emitters are there. So one we call it as an independent source emitters, and one more we call it as a dependent source emitter symbols we'll be using. We will be learning about, or we will be using this entropy to calculate the average amount of information which will be carried out by the source for the dependent sources and for the independent sources. So when we want to talk about the amount of information which is being carried out by the dependent sources, we will be using a Markov source. We will be using the properties of the Markov source, and through the use of these properties of the Markov source, we can able to calculate the amount of information which will be carried out by, or which will be exhibited some of the symbols from the source alphabet. After learning the measure of information, the next step is we need to convert these source symbols into source codes. So we will be using the source encoders. So basically the source encoders are nothing but it is a conversion of analog signals into digital signals. So we will be using a source encoding mechanism. So when you want to convert this analog signal into digital signal, we need to make sure that whatever the information which is generated at the transmitter end, it has to reach to the receiver successfully. And the information what we have generated in the source, it has to replicate at the receiver also. So in order to make this phenomena successful from source to destination, it is necessary for us to have a relationship between the conversion mechanism from analog to digital values and from the digital to analog values. So for that, we need to use some of the characteristics when we want to convert the analog signals into digital values. So for that, we will be using a prefix code and Kraft-Macmillan inequality property. So through the use of this prefix code and Kraft-Macmillan inequality property, it is possible for us to convert the source alphabets into source codes, so that from the source to destination, we can successfully decode and transmit the given symbol. So once we converted the analog signal into digital signals through the use of these properties, now the next step is, so what are the different types of source encoding algorithms are there we need to study. So in the module number 2, we are going to study about 3 important source encoding algorithm, that is Shannon encoding algorithm, Shannon-Fano encoding algorithm, and Huffman encoding algorithm we are going to use. So through the use of this algorithm, it is possible for us to convert the source alphabet into source codes. So means what? We have converted the analog alphabet which has been generated by the source will be converted into digital values. That's all details we are going to study in the module number 2. And in the module number 3, so once we generate the data, the next step is we need to transmit over the channel. So when we want to transmit over the channel, the physical channel has to be modeled in a mathematical fashion. So how we are going to model the channel, All those details you are going to study about in the discrete communication channel. So there are different types of channels we will be using depending upon the what type of source data we are transmitting from the source to destination, and it is necessary for us to know what are the characteristics of the channel and how best we are going to represent through the use of the mathematical tools. So in order to represent the channel characteristics, we will be representing the channel in the form of channel matrix, joint probability matrix. Through the use of this probability matrix, it is possible for us to represent the physical channel into mathematical model. And then once we studied this representation of the channel, the next step is how best we can transmit the symbols from source to destinations we need to see. Means we need to measure about so what with what rates the channel is possible for us to allow us to do the data transmission from source to destination. So for that we are going to use the channel capacity. So we need to measure the channel capacity. So if we know the channel capacity, then it is possible for us to restrict the amount of data flow from source to destinations. So we will be using problems and we will be solving so many problems in order to understand what is the effect of this channel capacity over the data rates when we do the data transmission from source to destination. So all those details we will be learning in the model number 3. Next, in the model number 4, okay, we understand this data has been generated and it has been converted in from source alphabet to the source codes, that is a discrete values we have converted. The next thing is when I transmit the data from source to destination, I should make sure that if there is any discrepancy is there in the channel, that has to be affected to the message what I have transmitted. Therefore, it is necessary for me to know whether an error has been occurred in the given data what I have transmitted over the channel. I need to understand. So in order to understand or in order to know the error has been affected for my data transmission over the channel, I will be using a channel coding scheme. So through the use of this channel coding scheme, it is possible for us to know at the receiver whether the data I have received, it has been successfully received without errors or with errors. So if it has been received without errors means then I can easily convert the digital values into analog values so that I can easily transmit from the original source information. If the error has been occurred in the given data what I have transmitted over the channel, then it has to be rectified. So we will be using a channel encoding algorithm, and there are different types of channel encoding algorithm. So among that, two important memoryless channel encoding algorithm we are going to study in the model number 4. So the one we call it as a linear block codes and one more we call it as a cyclic block codes. So through use of this linear block codes and cyclic block codes, it is possible for us to add some redundant information to the message vectors, and it is possible for us to know whether the error has been occurred or not during the data transmission over the channel. So mathematical representation and how to know the error has been present or not, we will be get to know from this model number 4. And in the model number 5, we are going to study about one more type of channel encoder. That channel encoder we call it as a convolutional code. And this convolutional code, whatever the operations which are being performed by linear block codes and cyclic block codes, the same operations these convolutional codes also will be doing. But the one of the difference between the model number 4 what you are going to learn and model number 5 what you are going to learn is that the memoryless and memory channel encoders. So in the model number 4, if any source it has been generated or it has been converted from one form to another form means so there is no dependency from one code block to another code block. But whereas in the case of binary cyclic code, so if you want to do the data transmission or if you want to do the conversion from one code block to another code block, it is not only necessary to know the message at that instant of time, but the previous message what you have coded, that also plays an important role in the conversion from one form of binary values to another form of binary values. So all those details you're going to study it in the convolutional codes. So one of the two important characteristics or two important phenomena what we are going to study it in the convolutional encoder is time domain approach and a transfer domain approach. So with the use of this time domain approach and the transfer domain approach, it is possible for us to create a channel encoding scheme. And once we have done the encoding mechanism, similarly we should go for the decoding operations. We will be using a Viterbi decoding algorithm. So through the use of the Viterbi decoding algorithm, it is possible for us to extract, or it is possible for us to decode the information from source to destination. So all those details you'll be learning in this module number 5. Now, so what are the textbooks we are going to refer for this courses? We will be referring Digital Communication by Simon Hiking, and one more important textbook what we will be referring is Digital and Analog Communication System by K. Shanmugam. And for the references, if you want to solve more problem means, then I refer for everyone to use this information theory and coding for the Ganesh Rao, and some part of the digital and signal processing by S.K. Mitra you can refer. And in order to understand this information theory and coding, so the prerequisite, you need to know the basic communication system, so that you are going to study about in the principles of communication system. So when you study the principles of communication system, you will able to understand what do you mean by source, what do you mean by channel, and what do you mean by a receiver. So there we are, our main focus is to transmit the data from source to destination, whereas here how best I can transmit the data without consuming much bandwidth. So therefore the channel, the basics of communication system, that is the principles of communication system, if you studied me, then it's well and good enough for you to understand this subject. Then so after studying this, so what are the outcomes you are going to get from this subject is that, so you're going to know how I can measure the amount of information in a given message you'll be learning, and you'll be learning about a different source coding algorithm, and with the use of this source coding algorithm you can do several projects which is related to audio processing, which is related to video processing, and also it is related to speech processing. And also you can evaluate whatever the coding schemes you have used, you can evaluate the performance of those coding scheme through the use of the channel capacity or through the use of the entropy which has been transmitted, entropy of the given source. Okay, so the remaining thing, everything we will discuss in the next section. Thank you.